The next panel is our session on compute memory storage, FPGA, high density GPUs. So the idea here is obviously this section of the day focuses on silicon and its particularly its role in the POP and in the data center, where CDNs use those different elements to process content as it's passing through their networks. I think without muddling the floor, I'm going to hand to you, Tim, silence my microphone and let you take us into the panel.
Okay, sounds good. And yeah, as Dom mentioned, this is compute, FPGA, GPU, general purpose computing, specifically how it applies to the world of CDNs and scaling video. And I'm going to go ahead and ask quickly for the panelists to introduce themselves, starting, and I'll just do left to right on the way that I see you all on the screen. So Avinash, I think you're first. Go ahead and just introduce yourself. Tell us a little bit about what company you represent and your background in the industry.
Sure. Thanks a lot, Tim. My name is Avinash. Hello, everyone. Glad to be here. I've been a video compression technologist for several years, working to deliver algorithms, solutions across the broadcast industry, the video streaming space, and also in the multimedia consumer electronics space. So at Xilinx, my team and I right now, we're focused on building encoders, designing algorithms around transcoding applications using next generation encoding technologies like H.264, AV1, and primarily we are focused on the live cloud encoding market. Thank you.
Good deal. Greg, you're next on my screen. And you may need to unmute.
I was double muted. Sorry about that. Yeah, Greg Jones with NVIDIA. I'm the product manager of our CloudXR, our streaming XR architecture that we just announced today. You can actually try from Amazon Web Services. So right at the edge is where we're trying to stream XR, VR, AR, MR.
And I think last time you were on this panel, you only had one axe behind you. Today, it appears that you've doubled up on the number of guitars.
Yeah. They're, now they'll really start growing. I think we'll see them. Now that there's two, we should see, some exponential growth back there.
Very good. Very good. All right. And then Nehal, I have you next on my screen.
Yeah, thanks, Tim. It's always a pleasure to be here. Hello, everyone. My name is Nehal Mehta, and I manage the CDN segment at Intel Corporation. When people hear about Intel, they often think of us as a silicon company, but in CDN space, we do much more than that. We work a lot with commercial and open source ISV vendors and SIs, and we are working very closely with most of the major CDN providers as well as OTT players. And our sole focus is to remove barriers and roadblocks for our CDN providers.
Very good. Thank you again for being on here. And last but not least, we have a representative from Kontron. Go ahead and introduce yourself.
Yeah, hello, my name is Antoine. I'm Director of Product Management for Kontron. Kontron, we do a lot of different things in media, mainly in media transcoding. We also provide a lot of different server for telco edge. What we bring here is we put together all this nice technology like from Intel, NVIDIA, Xilinx, and we put that together in a real application server you could use and integrate in your actual network.
Okay, and I want to start with a question for you, because you said you do integration across multiple types of compute and silicon. What are the kinds of innovations that edge computing are bringing to the CDN market? And I know we're going to have further discussions on edge computing later in the day, but just to sort of set the groundwork here.
Yeah, I think it's really interesting. All the edge computing, I think this will transform the CDN market. Because this enable a lot more processing to the edge. Let's say the traditional way for CDN is mainly caching of content. But then with all the trend of edge computing, you could end up really close to the user to have a very interesting processing unit. So pure software processing, but also a lot of different accelerator like GPU or FPGA. This could bring a lot of innovation to the CDN, including some funny things like new application like VR or cloud gaming.
Okay, got it. And let me work back across the panelists real quick on this. Edge computing, obviously, it's a term that we're hearing a lot more on. Nehal, from your standpoint, you know, from the sort of general purpose computing, what do you see edge compute doing for the CDN market?
Yeah, Tim. So from our perspective, you know, we are seeing at least two different approaches evolving. We have already seen the rise of like serverless compute technology in form of workers from some of the traditional CDN providers. It appears to be promising. And like Tom said earlier, you know, it's one of those things in pre-market stage. The other approach is the accelerator approach. And we know that CDN providers are continuously challenged to do more and more with less. And then you have space and power constraints at the edge. So the accelerators could be a great fit. We see it being used in niche use cases like smart stadium, or even for use cases around broadcasting for multiplayer gaming. And then there are use cases which are more ubiquitous, especially in security space. So one of the trends that we have been seeing is the rise in encrypted video content. Most of the web content is already encrypted, and video is kind of following up the same trend. The other trend we are observing is the edge nodes are becoming more and more powerful in terms of connectivity. So the only way to maximize your throughput is to offload your more compute-intensive functions, especially for more generic features across all the nodes. So in security space, you know, we see a need for TLS encryption, you know, need for deep packet inspection. And I think this is where, you know, accelerators have a role to play today. And definitely there are more emerging use cases, but I would say that, you know, many of them are in pre-market stage.
So Avinash, you mentioned obviously the acceleration that FPGAs do. What about from an edge compute standpoint? Are you seeing the concept of pushing FPGAs out to the edge of the content delivery network?
Absolutely, Tim, because like previous speakers have mentioned, there's emerging applications, all of which point to one thing, which is lower latency, which means, you know, the latencies have to come down for the next generation immersive experiences to give that next quality of experience, especially if they're more interactive, right? So to be able to do that and to be able to handle all this video in an interactive, low latency manner, I think we should be able to get accelerators in whatever form, FPGAs out there at the edge to be able to handle all that. Not to mention, there's these increasing ABR ladders, which do involve a lot of you know, compute operations, you know, for the video to be delivered. So it's not just the latency. Latency is definitely one aspect of it, but the other one is also we're moving towards much bigger and larger data sets, larger capable technologies. So to be able to handle all this and yet give the same or better, you know, seamless experience, you know, the acceleration at the edge is definitely you know, a need going forward.
Larger assets is a very valid point as you bring up. Greg, so from your standpoint, I mean, NVIDIA has typically been out there in the GPU encoding and transcoding space for media servers, obviously for immersive experiences, you know, pushing that at the desktop. But from an edge compute standpoint, where does NVIDIA see GPUs kind of playing a role?
But in the immersive experiences, everywhere, right? So all the way from data center to edge. And I think, you know, when you think of latencies and you think of edge, those GPUs, when they go out at the edge, right, they're pretty power hungry, right? The data center, the server GPUs, a 300 watt beast. The inference, you can get away with a 75 watt. So those GPUs out at the edge are going to be pretty expensive, right? So a lot of the to get those low latencies, let's say you're in the 10 to 15 millisecond latency. So I think what we'll see with GPUs is really specific workloads that absolutely require that low latency will be out at the edge. And then if you can get away with inference, let's say you're doing a VR, for instance, and you want to do some voice recognition. That voice recognition can probably happen 30 to 60 milliseconds inside, right? So you can start moving that to a higher powered building with a GPU in it, and you'll get a lower cost piece of compute. So, you know, with the GPUs, we see them everywhere, but we would really see the chain of disaggregated compute following that same path. Is, you know, let's do low latency stuff at the edge, but let's not overuse that GPU because it's expensive. Let's do as much as we can at the data center. And then if you have a device like a camera or something at the edge, if we can do any processing there and not even involve the network, let's do that processing, you know, on the device. So I think you really see a subtlety in disaggregated compute coming up, and that includes rendering for immersive, but also inference and AI type of workloads.
Yeah, you bring up the PowerPoint, and as Dom mentioned at the, sorry, not PowerPoint, you bring up the point about power. And as Dom mentioned at the top of the hour.
I have a PowerPoint on that, right, if you need.
I'm sure.
Yeah, sure.
And as Dom mentioned at the top of the show, you know, he and I have written about the greening of streaming, where we're looking at those power consumption issues. That's a really valid point about the fact that the edge will tend to be thinner, not just in terms of capacity, but also in terms of power availability. So your model on disaggregate, where you're talking about moving higher power consumption GPUs closer to the core as opposed to the edge, is a point well taken. Having said that, low latency video is, you know, moving along at a fairly rapid clip, at least, you know, if Apple is any indication in terms of low latency HLS. Will we run into a point where a couple of years from now, all video is low latency and therefore requires more edge compute to handle those things? Or do you think we're still 5 to 10 years off from sort of low latency being the norm as opposed to the exception?
It's a great question. So I do think this low latency, but there ends up being some kind of, you know, we have to meet that kind of, we've got, you know, low latency demands right now are kind of on this I'm trying to think of the curve that goes up really quickly, X squared type of curve, and I've lost the word for it. Exponential.
Hockey stick, sure.
Right. Yeah. But eventually, you know, the thought of, you know, I've heard various estimates, but we have like 200,000 to 300,000 cell towers right now, and for 5G to be fully rolled out, we need 800,000, right? That's a pretty significant CapEx for the telcos to carry. So I think somewhere our curve of exponential use cases for low latency video and just what our CapEx will do. So I do see that kind of stretching out that growth curve, because there's only so much capital that the consumer can put into the telcos quickly enough to keep exponential. So I see it kind of elongating in 5 to 6, 8 years will be the growth curve that really sees low latency. That's just my economic guess.
Sure.
And the technology's there, right? It's just how fast we roll it out.
Exactly, and I don't think we argue that the technology isn't capable, because it clearly is, but as you say, the CapEx side, I'm going to throw that open to the other panelists as well. Low latency, I mean, we hear a lot about it, and obviously CDNs, you know, are one part of the mix to deal with low latency delivery. What do you think from a compute standpoint? Are we a couple of years out from low latency as the norm, or do we have the compute and CapEx models in place now to be able to handle that? And I'll again throw that out from an FPGA standpoint, a general purpose standpoint, and then Antoine from sort of your aggregation model.
Yeah, I think we are at the beginning of this journey, because everyone said, okay, we would like to put that. I think Greg bring the point of the power and the location at the same time, where we should put the GPU. We could put that in the data center, or we could put that at the edge for various reasons. But it's important also to consider the physical location of those things and the condition. you need to get a specific telco condition, you need to have a very high reliability and maintenance. So he is right by telling the compute will be a little bit more expensive at the edge because you need to have a specific type of a server or condition. This is the type of thing we do, be able to take any technology from the data center, but be able to give them to the software developer at the right location, actually.
Okay. Avinash, Nehal?
Yeah, Tim.
Yeah.
So go ahead, Avinash.
Sure. Well, I was just going to add to Greg's point that, yeah, most of the technology, if not all of it, is there already. And immersive experiences and low latency interactive cloud gaming. These are the kind of typical applications that are going to lead us there. So definitely acceleration has to be a major part of it. So sooner than later, especially when 5G rolls out and the kind of timelines that Greg talked about, I think I'm in agreement with that. I mean, it takes time for these, for the infrastructure to be in place, for 5G to roll out, be tested. And on top of these applications can gain stream. And not to forget, I mean, if you want these to go at the exponential pace or to gain mass adoption, the acceleration also has to be so, right? Like if you want to handle video at that scale from those edges at those latencies we're talking about, you cannot just of course, accelerations like GPUs or FPGAs are a good start, but I don't think they will end there. And you'll have to go into more hardening, get better ASICs out there, which offer, the latencies we're talking about with no compression quality impact. Because at the end of the day, today, if you're talking latency, from a compression perspective, we're talking more bits. Right. So latency, almost always reduction in latency comes at the expense of more bits. And in the future, when you're talking latency becomes, or low or ultra low latency becomes a norm, so to speak, then we need those technologies to ensure that there's no compromise in the video quality. And that's still work in progress, especially if you are to do that at scale.
Sure, that makes sense. Nehal?
Yeah, so just to add to what was said previously, I agree that currently it's not a technology barrier. We have seen lots of new protocols being rolled out in the market, from SRT to CMAF to WebRTC. We are pretty much down to 500 milliseconds of latency across the continent for broadcasting. But I think the challenge is more to do with the economics of scale for certain targeted use cases. So, unless you're targeting a location where, you have very high density users in that location, it's going to be challenging to achieve that economics of scale to be able to, push your compute down further, to achieve that low latency. So that's just another aspect I wanted to share.
Okay. Now, we had a question from the audience, and then I'm going to come back to two other questions that I have. But one of the questions from the audience is, will mobile device capacity, and by capacity, we're looking at, the silicon and processing there, be embraced into the core network, or will it sort of always be forced to be extraneous capacity? And I'll open that up to any of the panelists. I know obviously GPUs and FPGAs aren't in most mobile devices, but it does seem like we have a significant amount of capacity sitting out at the edge, so to speak, on mobile devices that could share within a local area network. Do we ever expect that we'll embrace that as part of the network core, or it's too far afield to be able to look at from a core standpoint?
Yeah, it's hard to think of computing being stretched across the mobile devices, right? Where one mobile device is helping another, but certainly most of the immersive strategies I see, the gaming strategies, are going to put a max load on the device, just because if you lose any kind of connectivity, you don't want to lose your experience entirely, right? You might be willing to live with a degraded experience, lower end graphics just because you're not connected to a heavy compute. I think as we go out into IoT though, so mobile becomes not just phone, but it becomes all the sensors out there, and maybe some sensors have a bit more power. Then it could be really interesting to see workloads spread across, load balancing across the actual IoT devices.
And those devices would tend to have fixed power as well, as opposed to battery power. IoT. Yeah, fair point. Anybody else?
Power, and you start seeing the XR2 and the Tegras out there. The different chipsets that'll be in the mobiles that have some compute on them. Yeah.
Fair point. Anybody else on that particular one?
Yeah. One thing I would like to share is, we are observing that there's definitely interest in concepts like P2p technologies, not from the standpoint of, applying that technology on the devices itself, but even on your edge tiers in your CDN, right? If you were to deploy P2p technology, you could redefine the concept of origin, where instead of fetching the content from the origin, you can now fetch the content from another nearby edge location. And maybe, the thinking is, this could potentially be pushed further down, remains to be seen. But, there are some interesting evolution around newer technologies that we are seeing out there.
Yeah, and it's interesting that you say that, because I'm working on another article in the algorithm series that I've written this year for streaming media, and we're looking specifically at things like that offloading with P2P, especially as we move toward the Internet of Things. Antoine, Avinash, anything more to add?
For sure, the P2P technology is kind of an option, but still have some. I see two difficult drawback on that. Is most of the time they are battery device, they are mobile device, so you try to manage the battery, and it's a big deal to use it. And also you have like the bandwidth issue, or you charge the user, because of course, if the user became like kind of a broadcaster, he consumes a lot of his bandwidth. So it's kind of difficult to manage that. I will say on the economic point of view, because you could suppose this help the service provider, so he will maybe not charge for it, but it's still complicated. So I think because of that, you have kind of a balance where you should put this workload. Is it better to put that, let's say, really far to the edge, like close to the antenna or so on and so forth, instead of using P2P? So this is why I think we will see more and more compute resource and accelerator really far to the edge, like in the cell tower or something like that. Because in the cell tower, you still have limited power, but it's not battery power.
Got it. So Avinash, let me switch just slightly, and if you've got anything to add to this, feel free. But what about acceleration and the necessity of it for live video delivery? What are the benefits we get for accelerating live video?
Well, yeah, to the previous point, yeah, I don't have too much to add, except that obviously battery power is the most important aspect, and there's also the other thing, that the economics of it, right? Like what's in it for a mobile user, like when it comes to sharing that bandwidth across, right? And how seamless that experience can be. So it's both from a technology, meaning battery, from experience perspective, and also from the economy perspective. So these all have to tie in together. So it kind of seems far-fetched, also, although I wouldn't rule it out, but it's definitely more far-fetched.
You make an interesting point. If somebody's having to constantly run out and buy a top-up card to cover the P2P delivery to somebody else, that certainly could be a disincentive.
Exactly.
So acceleration for live video delivery.
Yeah, so coming back to that, yeah, so video is complex, right? Like for a simple 1080p 60 live video, right? A single 32 by 32 transform, for example, will take more than 2 trillion multiplication per second alone, right? And tie that together with a whole bunch of other decisions that the encoder has to make, meaning the encoder, the way it works, or transcoder for that matter, is that it has to, for every specific segment of the video, it has to look for the best modes, the best encoding parameters, the optimal block sizes, transform sizes, etc. And then it has to iterate over thousands of such combinations. And for each and every segment, it has to come up with that perfect fit, which gives you the best visual experience with the lowest bits possible. Right? In encoding, transcoding parlance, we call this rate distortion optimization. So, and the intricacy here is that it ties together both the complex math calculations together with decisions. And that's why it is very important that this has to be accelerated, because if it were one or the other, it could be much easier. But the fact that these are both convoluted together, and that is absolutely needed for you to be able to get those bits lowered, makes acceleration very lucrative, right? And the other thing, so in the effort to do this, as we have, gone from as we have seen from the codec evolution over the last decades, right? Moving from H.264 to other newer technologies like HEVC or AV1, right? The effort has been to get, say, 30 or 50% reduction in bandwidth at the same visual quality. What has resulted is that the complexity, what I just talked about, it has gone up like tenfold, right? Because everything today is being done at the expense of computations at the transcoding side versus the consumption side. So the consumption side is fairly seamless, whereas all these computations have drastically grown up. So, without acceleration software-only models, they can work if they're offline, for example, or if, for simple content, or when the resolutions are lower, when the latency requirements are not drastic, etc. But as you know, the world is actually moving towards higher technologies. We're moving towards, bigger resolutions and whatnot. So, accelerations like FPGAs, they are, they make perfect sense, not just from, the seamless delivery and the computations point of view, but also because of these computations, it's more optimal from a power perspective, and from a rack space perspective, and also from a cost perspective, right? So all of these tie in together in this decision.
Good. All right, and then one last question. Nehal, I'm going to start with you, and then we'll just work our way across the panel. What's the impact to content delivery network providers in a post-pandemic world? I mean, right now, everybody seems to be up in terms of their numbers for 2020 versus what they projected, but moving forward, say mid-2021, what's the impact on CDNs in post-pandemic?
Yeah, so Tim, from CDN providers' perspective, most of the CDN networks have always been designed for big traffic. And despite the growth in traffic, for the most part, most of the CDN providers have done fairly good in absorbing the spikes. The challenge has been more with the underlying carrier network. So definitely, there is lots of focus in making the CDNs more network aware. We're also seeing more and more interest from CDN providers and more of like virtualized and cloud native technology so that they can scale on demand. It's nowhere at the inflection point. Most of the CDN deployments still run on bare metal today. But that's one of the shifts that we are seeing. There's also impact to making the CDN providers to think more about very unique features, like features that would allow the users to watch together socially, but remotely. So that is rise in unique features like app synchronization. We are seeing the OTT players launching new features like watch together or watch party. So it's definitely driving the CDN providers and the OTT players to innovate and think differently.
Okay, Antoine, from a Kontron standpoint, what do you see the impact on CDNs post-pandemic?
I think the pandemic will change a lot of things like work from home. In the last year, this panel was most likely on site, right? Everyone was not at their home. So this all work from home will stay, because we did an internal survey and all people working for us would like to continue to work from home. So I think this will increase for a very long time the quantity of video we see on the network. and it was already the main driver of the video. So I think we will see a lot more need for transcoding. And yeah, transcoding need also some accelerator, hardware accelerator. You could do that with the FPGA. You could do that with the GPU. So we're working actually on a new product in order to be able to accelerate transcoding based on the new Intel discrete GPU. So I think we will see really a lot more video and transcoding demand for all the edge and for CDN.
Okay, good deal. Greg, what about you? What's your take?
Yeah, I definitely see the pendulum has swung really extremely to work from home and be remote. So it'll swing back again, but I don't think it ever hits the norm, you know, that we were used to. So I think CDNs, and one of the drivers of that is not just people loving to work from home. You know, for one thing, I'm busy enough. I can't imagine how I could travel. I don't have time to drive to the airport anymore. So much less take a multi-hour flight. But I think the CDNs have been asked to re-envision themselves over the pandemic. So I think as much of a driver as demand will have, it's the CDNs thinking new thoughts about what they can do. And so it's really a bimodal thing.
Fair point. Avinash, you get the last word.
Yeah, from my perspective, I look at it as just acceleration, right? Because, you know, all this, the world was already moving towards much of this anyways, and the pandemic just served to accelerate, skyrocket, you know, the newer applications to where they needed to be. So, so we're going to be seeing more of this work from home, and scenarios like these will, I mean, of course, post-pandemic, maybe in a year, a couple of years from now, things will be here to stay for the long term, or many of it, or most of it, right? Maybe not all of us would be working from home and doing the same things the same way we were doing today, but several of these effects in the form of conferencing or, you know, the social media interactions, the experiences, the low latency applications that we just talked about, all these are here to stay, and they have definitely been accelerated now. And a lot of things have been also proven to work, you know, in a fairly, you know, which we wouldn't even have thought about in say 2020. They have worked in 2020, right? So that is also very
test case to production almost without knowing we were doing it.
Exactly. So, you know, so it's in that sense, you know, this has driven the technology much more than what we could have done without it. Right. Thank you.
Dom?
That was an awesome panel session. Thank you so much. That was a great session. This is one of my favorites as we're getting these regular sessions in CDS established, and it's important that we think about the real fabric. So I'd like to thank you all. So Tim, do you want to just thank your panel?
Yeah, thank you very much to each of you for providing both different perspectives and also sort of consistent perspectives as well.
You bet, Tim. It's a pleasure. Thanks.
Thank you.
Thank you.
Thanks, Steve.
It's been a pleasure.